Hello everybody, tonight we are doing compound interest. So, compound interest, couple words we need to know right up here. Quarterly, 4 quarters in the year. Monthly, that means there's 12 months. Semi-annually means twice annually. Once a year. Semi-annually, twice a year. The formula looks very similar to what we have been working with, but now look, divided by n and times n up here. So you're taking the rate, dividing it by how often you're checking in, and you are now checking in that many more times, so it's n times what the original time frame was. All right, here we go. Let's look at number 1. We invest $500. That's your P. Yearly interest rate of 4%. That means we will use 0.04. We are going to look at this. We're going to be doing it in 10 years, and we're going to do a frequency of just once a year. So what we've already been doing. So you'll say A equals 500, 1 plus 0.04 over 1, and then 1 times 10. Okay, type that in the calculator. After 10 years, you will have $740.12. It's never going to say what to round to when money's involved because you know it's nearest hundredth. Okay, now coming in here, we're going to interest applied 4 times during the year. Notice quarterly. Why does it make sense not to just multiply by 1.04? So 1.04 is what we were looking at right here. If I multiply 4 times by that, I've now turned that into 4% each time, which would be 16% overall per the year. Where when we're looking here at Z, we want to take that 0.04 and say that if the year rate is 4%, each quarter is 0.01 or 1%. And we're going to see how that changes things here. So now, quarterly compounding. So we start the same. A equals 500, 1 plus my interest rate of 0.04 over, I'm checking in 4 times now. So the interest rate is divided 4 times. And then you'll do 4 times 10 up there. So it's still an exponent. It's now an exponent that we've checked in 40 times over the 10 years. And that now gives me $744.43. All right, next page. Okay, top 1, multiple choice, always nice. We're going to invest $1,000, 2% interest, compounded monthly. How much is that going to be worth in 20 years? So first, this is my P. This is my original amount. Change your decimal to 0.02, moving it over 2 places. Monthly means 12. And our time is 20. Divide that rate by 12, and then instead of just checking in every year for 20 times, I'm going to check in every month, so that will be a much bigger number. Type that in. Here we go. Let me show you that. Slowly. New document. So we have 1,000. Open a parentheses. 1 plus, I'm going to make a fraction, so control division. 0.02 over 12. Notice how I've made it a big space again. Close the parentheses. Use the caret. There it is. And then we will do 12 times 20. And there we go. 14913. That's going to round up to 33. All right, one more. First part's easy. In fact, I'm going to let you set that up. They're saying semi-annually. It's not easy. It's what we just did. So follow the steps of everything. Here is your P. Here is your interest rate. And we're doing it semi-annually, 5 years. I'm going to give you the answer. that is going to be 1104.62. All right, bottom one. If you have questions on that, obviously, let me know. How long does it take to the nearest year? Now they're telling you how to round to make 3,000. So 3,000 is what I want it to be. I'm starting with 1,000. Interest rate 0.02. We are still compounding semi-annual. It's the same one you just used. I was checking twice a year, and I'm looking for what that t is. So to solve this, here is the variable. It's up in the exponent. I'm going to have to use logs, but I have things in the way. So first, divide by 1,000. I'll get 3. Okay, looks like that one that we did during the scavenger hunt. Got a lot of stuff going on. Exponent is the variable, so I switch it. Log base 1.02 over 2 of loop over 3 equals 2t. Type that right in the calculator. You'll get 110.4096 equals 2t. Divide by 2. T is equal to 55.2, or to the nearest year. To make the 3,000. At 55 years, he will not have 3,000, so we have to go up to 56 years. All right, flip over to 67. Here we go. Here we go. Here we go. Now we're going to talk about compounding continuously. Compounding continuously has its own separate formula because you need one more thing to memorize. You'll notice original amount is still P, ending amount is still A. Instead of having a rate of 1 plus the rate, it is now E, that number that we love, to the rate times the time. And it looks like PERT, so you can remember it by spelling the word PERT. The R and the T are the exponents. You have to be careful. Here we go. We invest $350 in a bank, 2%, and it is continuously compounded. Okay, so that's the difference word there. When we are continuously compounding, we're going to use PERT. So we say A of t equals 350, that's my original amount, times e to the 0.02 times t. So there's my formula. And then we'll look at B. 20 years, what's that worth? So A of 20, that's my t. 350 times e to the 0.02 times 20. Remember, when I'm typing this in, turn on, there you go. 350, the E button, right there above the parentheses, e to the 0.02 times 20. Look at that. We have made money. 5.22, 14 cents. See how the 0.138 will round up. All right, opposite right here. When will it reach 400? So 400 is the end. 350 is the beginning. Still 2% is the rate. Looking for time. Is the exponent all by itself? No, base. The 350 is in the way. Divide. Divide. Okay, simplifies down to 8/7. Now, need my logs, my friend, the log. But when the log is base E, log E sounds funny, so we say natural log. Natural log of 8/7. Boom. Type it in the calculator. Remember the natural log button above the E. Look at that, how exciting. Natural log. What did I say? 8/7. And you get a disgusting decimal. Always nice. Divide, so I'll write that down, 0.1335.02t. Divide by 0.02. Bam! 6.7. Well, it's 6.67 repeating. So nearest tenth, this one said. You tell it exactly nearest tenth. Okay, last one. Woohoo! We invest 1050, interest rate, compounded continuously. Fabulous. How much money will she have in the account after 5 years? So let's start. We start with 1050 times E, 0.055 times the time of 5 years. Her name is Julia, or Julie. I'm going to call it J of T. So there's my function. And I type that in. 1382.357. So money, 1382.36. All right, last one. Here we go. In what year will she have 5,000? The 5,000 is the amount she wants to end with. And we are looking for time. Step 1, divide. Okay? That reduces 100 over 21. Now, I want you to finish this one. Okay? It's just like the setup up here. Look at what pieces match, where they go. The answer is in the 28th year. You show me the work to get there. Okay? Turn it into a log and go through. Have a great night.